so we have our first example here under trigonometric substitution. Alright, let's go. So now we always know that with this, you cannot solve this by trig substitution. Okay, we can solve this by we can solve it by u substitution. Okay, but here you can also rewrite this. Okay, you can also rewrite this. You can also rewrite this and solve it. You can also rewrite this and solve it using inverse trigonometry. I know of that and I have taught you of that, but not all the case that you can do it in such a way. So here, let's use trigonometric substitution concept to do that. And I hope you know what I'm talking about. If you want to use inverse trigonometry, you can do it this way. You can factor 25 out, alright? You get 1 plus s squared over what? 25 ds. Okay? And with this, you get 1 over 25 out here. And here you get 1 over 1 plus s over 5. Because 25 is what? 5 squared. Then factor what? That out. Then you set your u. I just want to run up with this. I don't want to use this method. Okay? And here you get s over 5 to be the u. Then the u will be equal to 1 over 5 ds. Okay? So ds will be equal to 5 du. 5 du, cross multiply, 5 du. So you get 1 over 25 integral of 1 over 1 plus u squared. 1 plus u squared. And the ds is 5 du. Alright, 5 du. Good. So that is that. And we know that this will go to this. So we get 5 over 25 here, and the integral of 1 over 1 plus u squared du. And you know that this is just going to give you tan inverse. Alright, so here we get 1 over 5 here, 1 over 5 integral of, when you integrate this, you get tan inverse of what? Tan inverse of u. Tan inverse of u plus c. And it's going to give us 1 over 5 tan inverse of u. And u is what? U is s over 5. S over 5 plus c. So here I'm aware, and we know that we can solve this by inverse trigonometry, and I have taught you of that. Is that not so? So generally, you can see that if you have 1 over a squared plus s squared, this is just 1 over a tan inverse of s over what? A plus c. And I have taught you of that. Alright? But here, I want us to use our idea or our concept. Alright? I want us to use our concept in trigonometric identity to solve this. So to do that, you will see that you get the same results. Okay, so doing that, you can see that here we can rewrite this as 1 over, we can rewrite this as 1 over 5 squared plus s squared ds. And here, very good. We can see that we can bring out 5 squared plus s squared. Then to transform it in the square root form, we can write as this. It's still don't change anything, because this will cancel this, you get the same as this. So to take it to that form, this is going to represent what? A hypotenuse that we know. So we are going to get 5 squared plus what? S squared. And here, we know that is tan theta, which is y over what? Y over what? The x, alright? Or the opposite over the adjacent. So here, that's supposed to be a variable. The top supposed to be a variable. So you let it be s here be a over a. Then s is going to be equal to a tan theta. So the s is going to be a sec squared theta d theta. Alright? So by substitution to this, you are going to get integral of 1 over 25 plus s is what? Oh, this is supposed to be 5, because the a here is 5. 5, alright. So here we get the s is 5 tan theta, so 5 tan theta all squared. And the ds is 5 sec squared. 5 sec squared. 5, what is it? 5 sec squared theta d theta. So here we go. Now you get 1 over, this is 25 plus 25 tan theta squared. And here we get 5 sec squared theta d theta. So now we can see that 1 over here, we can factor 25 out. So 25 here is 1 plus tan squared theta. And here we get 5 sec squared theta d theta. You see that? So this can cancel this. You get 1 over 5 integral of so here we can get sec squared theta over the inside, which is 1 plus tan squared theta. The 5 cancel this to 1 over 5. So it says so the theta. Very good. Nice. Hope you can see what you are getting. But here, the down. As I said, anytime we do a substitution of s is equal to a tan theta, you need a trigonometric identity of what? Sec squared theta over. So you have to know it of 1 plus what? Tan squared theta. So in place of this, we are going to do the substitution. So sec squared theta over, this is what? Sec squared theta. Okay? Sec squared theta over the theta. That is all. Yes, substitution. So here we get 1 over 5 integral of, here is what? Sec theta, so this is 1 the theta. 1 over 5. And when you integrate 1, when you integrate 1 as respect to theta, you just get theta plus c. But don't forget, after you are done, you have to transform back to what? The s. You have to transform back to be in terms of what? S, not what? Theta. We just use the idea of trigonometric substitution to get our question solved. So here, when you end here, you say back theta is equal to, we know that here, tan theta, we know that here, tan theta is equal to 5 over, s over 5. Therefore, theta will be equal to tan inverse of s over 5. Alright? So instead of writing theta here, we write 1 over 5 tan inverse of s over 5 plus c. Oh! The same answer we had in solving it using inverse trigonometry. And you see, we are resolved in the same answer. Thank you. Let's look at our next question. Alright, so let's look at our second example. 2. Integral of 1 over 25 minus s squared ds. 1 over 25 minus s squared ds. Now, as I said, with this one too, you can solve it using inverse trigonometry, alright? Because we know this to be a form that we have come across before. So here we get 1 over 5 squared minus what? X squared ds. So let's just go by what we are doing in inverse trigonometry. So here we transform this by getting it in the form 5 squared minus 1 x squared all squared. So here we get theta here, and you know, is this going, which one? Sec, sine, and tan, which one? First of all, before you know which one, you have to know the one. You have to first know one side. And you know that a hypotenuse can be what? Negative. So this is what? Positive. So we have the 5 here. And if the 5 is here, then sine theta is what? Opposite over the hypotenuse. Opposite over hypotenuse. And the hypotenuse is what? 5. Then we want to get something like s over a constant. S over a constant. That means that the opposite should be x, and here will be the side because of this negative. 5 squared minus what? S squared. So here is s. So we get s to be 5 sine theta. So the s is going to be 5 sine theta d theta. When you differentiate sine, you get what? Cos theta. Very good. So here by substitution, you can see that we get 1 over 25 minus the s is what? 5 sine theta all squared. And the s is what? 5 cos theta d theta. Very good. Let me change my marker. So here we can see that we get 1 over 25 minus 25 sine squared theta 5 cos theta theta. And here we can factor 25 out. 1 minus sine squared theta 5 cos theta theta. This goes to this 1 over 5 integral of 1 over 1 minus sine squared theta. Hey, what is coming? Cos theta d theta. Hey, but we know that. Hey, I'm learning something. Trigonometric what? Identity. So we know that, as we said, anytime you do the substitution of s is equal to, or anytime you introduce the sign, you will definitely need cos square theta. And cos square theta is equal to what? 1 minus sine square what? Theta. So this 1 minus sine square theta is exactly cos square theta. So 1 over 5 integral of 1 over cos square what? Theta multiplied by cos theta to theta. Very good. Is there any problem somewhere? I don't think so. Okay. So this will take one of this and we get 1 over 5 integral of 1 over cos theta, because here is cos square d theta. And we get 1 over 5. Now, integral of 1 over cos is what? Sec. So here is sec theta d theta. Very good. So the question now coming here is that, when you integrate sec, what are you going to get for that? So we know that first of all, let's come back and check. Okay. We know that when you differentiate this, you get this. And what I did here is that I factor 25 out, 1 minus this, that, and this cancel this. And this one here is just what? Cos square theta. So cos square theta, so that's that. So now, when you integrate sec, what are you going to get? Don't forget that you know that when you differentiate tan, you get sec square. That means that when you integrate sec square, you get tan. But when you integrate sec theta, you are going to get ln sec theta plus tan theta plus c. So this is what is going to give you. But bear in mind that we don't want it in theta. We don't want it to be in terms of what? Theta. So we need to go and find out what this what means. Alright. Alright, so this is just going to give you that. But we don't have to leave it in terms of what? Theta. Okay? So we are going to do something. And what we are going to do is that watch. What we are going to do is just simple. We know from here S5, and here is what? Square root of 5 square minus S square. Just from here. And there is 25. So now, we are going to use this Pythagorean identity to know sec theta. So what is going to be sec theta? Straightforward. Sec theta is r over what? X. That is what? The hypotenuse over the adjacent. So here we are going to get 5 over the s is the square root of 25 minus what? S squared. Then we go for tan theta. And tan theta is y over s, which is what? Opposite over adjacent. And that is s over 25 minus what? X squared. Very good. So instead of writing this, we don't want it in terms of what? Theta. And here too, you don't have only theta there and you are going to say, okay, then let me take the inverse. So theta is going to sine inverse. No. So just know the whole of the sec theta and the tan theta. And by substitution, we are going to get 1 over 5 1/5 ln sec is 5 / square root of 25 minus what? S squared plus, here the plus or minus, check and do it and do the right thing, but I'm sure it's plus, and tan theta is S over square root of 25 minus what? S squared plus C. So finally we get 1/5 ln 5 plus S over, we can achieve the same common denominator, alright? So that is 25 minus S squared plus C. So this is going to be our final answer, and that is the general solution. Alright, let's look at our third example. Let's look at the second example. We know that this is the same as 1/5 squared minus what? S squared. But we want to generate it. So let's create and destroy. Alright. So create and destroy. 5 squared minus S squared. And we see what we are using. Okay. So here, know that the positive will be the hypotenuse. So this one will go for 5. And which one will come here? Which one will come here? So let's try. We can see that sine theta is equal to what? Opposite over what? Sine theta is opposite over the hypotenuse. So the opposite should be a variable. So x. So the opposite is what? X over, and the other side, so the opposite over what? The hypotenuse. So here will be the 5. So this whole thing should be here. 5 squared minus what? S squared. I hope you can see from here. Alright. So S is equal to sine theta. Sorry. So the S will be equal to 5 cos theta d theta. So by substitution to here, we are going to get 1 over the square root of, but we know that here, even if you create and you destroy, it's still the same thing, alright? But you don't worry, let's bring it. So here we get 25 minus the S squared, and the S is what? 5 sine theta. 5 sine theta. 5 sine theta squared. And the S here is going to be 5 cos theta theta. So also we have to introduce this so that we can destroy what we have introduced here. So here we are going to get cos theta d theta over. Now here we are going to get, in fact we can forget about writing the square root, okay? So here it is going to be 25 minus 25 sine theta, sine squared theta. So here we are going to get, cos theta over 25. And when the 25 comes out, we are going to get 5 here. Okay? Because we are going to take out square root of, here is 25. We are going to take out square root of 25 out, and that is 5. So let me do it straight away. 1 minus sine squared theta, and get the theta here. We know that only the inside. There is a mistake here. This one, we forgot to bring it. So here is 5. So here we get 5 here. This cancel this. So go away. We have it. We don't more have it. So here we get square root of. Now 1 minus sine square is what? Cos square theta theta. So here this cancel this. Cos theta over cos theta theta. This cancel this. Integral of theta. Integral of 1 theta. And when you integrate this, you get theta plus c. But if sine theta is equal to s over 5, then theta will be equal to sine inverse of s over 5. Hope you can see that. So here we just get sine inverse of s over 5 plus c. So that is going to be that for that. So anytime we have something like this, it's just going to be sine inverse of what? S over 5. Alright, anything in that form. So that is the solution for that. That's going to be the solution for that. Okay. Alright, let's look at our third example. Okay, so in our third example here, it's going to be a nice question. We have to write this in a form. Alright, so here is the same as 2s all squared. Because it's supposed to be something squared minus something squared. And this, for our Pythagoras, the theta is here, 90 degrees is here, alright? And always the hypotenuse will pick the positive, so this is the hypotenuse. Now, with sine, sec, and tan, which one is going to help us? We know that here tan is even out because here is negative, so tan is out. Sec and sine, which one is going to help us? Which one is going to help us to get a variable over a constant? So we can see that sec is r over x, or opposite over the adjacent, which is failing here, because the hypotenuse sec is equal to the hypotenuse over the what? The adjacent, which is failing here because the hypotenuse here is a constant, so failed. Sine, this is going to be opposite over the hypotenuse. Very good. So sine theta is opposite over the hypotenuse, and hypotenuse here is 1. So we are going to get a variable over a constant. So what is going to be that variable? And that variable is supposed to be at the opposite. So here will be s. Then this one will be this 1 minus 4x squared. Alright. Please, as I said, don't chew it. Don't chew it. If you learn mathematics by chewing formulas, then you will die on your way. Okay, so s is going to be equal to sine theta. But anytime some people chew that anytime you have this, you do substitution of this, but actually know where it's coming from. And me getting this is also important. So here we get the s to be equal to cos theta d theta. So by substitution, So by substitution, 1 over wherever you see s, put what you have there. So what is s? Sine theta squared. And what is ds? Cos theta d theta. So here we have integral of 1 over 1 minus 4 sine square theta cos theta d theta. Is there any problem here? back again. We have this to be this to be that. Oh, there is a big problem here. Do you know that problem? Now, the S that we are representing here is supposed to be 2S because we represent the inside here by this. So here is supposed to be 2S. So here is supposed to be 2S. Here is supposed to be 2S. I hope you can see that. Alright. So that place is supposed to be, let's do it well. So here is supposed to be 2S. Okay, so here we get 2S is equal to sine theta. So S is equal to half sine theta. So the S is going to be half cos theta d theta. So by substitution, S is ds is half, and also I forgot to bring the square root. Let me clean everything. Let's move on. I hope here is clear because the inside here is supposed to be everything for the S. So that's the only thing that we forgot to bring. Let's move on. It's not that easy, but we will get there. Alright. So ds is half cos theta d theta. And here we have 1 minus 4 s squared. And the s is half sine theta. Very good. Very good. In fact, if you think there is a mistake, you should be able to verify it quickly. Because here you get 1 minus, and when this, don't forget that here is a square here because it's all squared. Okay? It's all squared. Where is S? So when you're putting in S into this, we are putting in S into this, not this. Be careful, not this. Into this. That's why we are having 4 multiplying the S. And the whole of the S is this. So here you are going to get 4 times 1 over 4 because the square will affect this. Sine squared theta. And here we are also having times half cos theta d theta. This will take away this. We are going to have here the half come out. Then 1 over the square root of 1 minus sine squared theta cos theta d theta. But we know that this is equal to what? Cos squared theta is equal to 1 minus sine squared theta. So we get everything here to be half 1 over the square root of, only the inside is what? Cos squared theta. Alright? Which is multiplying by cos theta d theta. So this take away this. Okay? So when that happens, we get half integral of 1 over integral of 1 over cos theta d theta. This take away this. We get half integral of 1 d theta. Half sine. I'll be straight away, but when you integrate this, you get theta plus c. Right? And here simply we know that theta is equal to what? Sine inverse. So theta is sine inverse of 2s over 1. So we get sine inverse of 2s. So therefore we have half sine inverse of 2s over 1 plus c. So in this case, that is going to be the final answer for that. That's going to be the final answer. Okay, let's look at our third example. Please, in the second example, let me make this correction. We have 1 over 25 minus s squared dx. Please, it's supposed to be square root. Okay, it's supposed to be square root. So don't forget to bring it. Okay, it's supposed to be square root. That is why when it's clear off, you are going to get it in sine inverse. Please, it's going to be square root. Okay, so with this, we write it in the form that we can solve by Pythagorean identity. So here, you create, then you destroy, minus, you create, then you destroy. You see, this after this, you get this, after this, you get s squared, so it's the same thing. So now, a constant square minus a variable, and the whole variable is this. So when you apply the Pythagorean, the constant is a positive, so that will come in square root of 2. So which one will we go by? Here is negative, so forget about that. Sine is y over r. That means that it's supposed to be sine because sine is sine theta is opposite over what? Hypotenuse. So the hypotenuse is the constant. So we are going to get sine theta is equal to opposite over hypotenuse. Hypotenuse is square root of 2. So the opposite is supposed to be the variable of this, which is square root of 3x. Square root of 3x. Alright, so here is supposed to be the other side, and that you can write 2 minus 3s squared because this is the same as that. So square root of 3s. And with this, when you make a subject, then you differentiate. You get square root of 2 sine theta is equal to square root of 3s. Alright? And when you divide both sides by square root of 3, you get s to be equal to square root of 2 over square root of 3 sine theta. I hope you can see that. Divide both sides by what? Square root of what? 3. That's what you're going to get. So here you get s to be equal to square root of 2 over 3 sine theta. So the s is going to be square root of 3 square root of 2 over 3 cos theta d theta. Hope you can see that. So let's go and do substitution into this. 1 over square root of 2 minus, okay, 2 minus, here we get 3. What we have for x? Please, the s is the whole of this, which is square root of 2 over 3. Square root of 2 over 3 sine theta. Sine theta. And the theta and the s that we have there is square root of 2 over 3 cos theta d theta. Hope you can see that. So this we are going to get 1 over square root of 2 minus. Here we get 3 times. This square will remove this root, so 2 over 3 sine square theta times square root of 2/3 cos theta d theta. This will cancel this. So we get square root of 1/2 minus 2 sine squared theta, and this is a constant. So we get square root of 2/square root of 3 here. So cos theta d theta. Very good. So here we can factor out. So here we can factor out 2 here. So we are going to get 1 minus sine squared theta cos theta d theta. And here we get square root of 2/square root of 3 integral of here. We can also bring out square root of 2. 1/square root of 2. This is pure, this is just algebra. Okay? And here will be 1 minus sine squared theta. Alright? Cos theta d theta. Hope you can see that. Very good. So now with this, with what we have here, you can clearly see that this will take away this. So you get 1/square root of 3 integral of 1/, and here the inside here that we see is cos squared. So here is cos squared theta, and here is cos theta d theta. So this also take away this. So we get 1/square root of 3 integral of this to take away this. So we get 1 d theta. So 1/square root of 3 theta plus c. And we know that sin theta is equal to this. So therefore, theta will be equal to sine inverse of square root of 3/square root of 2x. That's going to be what? Sine inverse. So by substitution, we get 1/square root of 3 sine inverse of square root of 3x/square root of 2 plus c. So that is going to be our final answer for such question. So simply you can see that anytime we have a constant minus a variable, we are just going to get Alright, let's look at our fifth example. Okay, so yeah, let's move on. Our fifth example is involving with what? A definite integral, because we have the lower bound and the upper bound here. Now straight away, we know this is going to be 2, 1 here is going to be square root of 3, 1/1 plus what? S squared dx. Now to integrate this, we know that this is a definite what? Sorry. We know that the integral function is what? Tan inverse. So straightforward. 2 tan inverse of x plus c. But here we are not going to add the plus c because of the definite integral. So we have 1/square root of 3. So we have 2 tan inverse of square root of 3 minus tan inverse of 1. And with that, we are going to get calculator. And with that, we are going to get tan inverse of square root of 3 minus tan inverse of 1. And we set it in a degree move, and we get 15. So here will be 15. So when you multiply this, you get 30, not 30 degrees, but 30 square units. Because this is what? Area. That is what? Integration. Good. So straightforward. It's tan inverse. So no more going back any long approach. 6. Integral of 0 square root of 2. 1 over 4 minus s squared ds. Having this also, okay, so having this also is a definite integral, alright? It's a definite integral, so we go straight forward. We go straight forward. So now we have integral of square root of 2, 0. Here we have 1 over square root of 2 square minus s squared dx. Alright, so we move on. Now we know that here it's just sine inverse, alright? This is just sine inverse. So straight away the integral is going to be sine inverse of s over 2. Constant minus variable. So that is sine inverse. Plus, so no more plus c, but we bring our 0 square root of 3. So straight away we get sine inverse of square root of 3 over 2 minus sine inverse of 0. So on the calculator, we have a lot of questions to solve under this video, so no more going by the long method. Square root of 3 over 2 minus sine inverse of 0. So we get 60. We get 60, 60, 60. And that is that for that. Alright? Good. And now with this question 7, we have integral of negative 2 square root of 3, 1 over 5 square root of 4 minus s squared ds. So with this, we can rewrite this as 1 over 5 square root of negative 2 square root of 3, 1 over 2 squared minus 1 s squared ds. And what we have here, constant minus a variable, constant square minus variable square is a sine inverse. So straightforward. 1 over 5. So here we get sine inverse of s over 2. You can go by that long method. We are all going to get the same answer. Okay. So then we bring negative 2 square root of 3. Alright? And when you do that, you get half sine inverse of square root of 3 over 2 minus sine inverse of negative 2 over 2. And we get sine inverse of square root of 3 over 2 minus sine inverse of negative 2 over 2. We get 150. Then we multiply by 1 over 5. We get 30. So here we get 30. So that is going to be that. Alright. Let's move to our 8th example. Our 8th example. And we'll see how that is going to be. Question 8. Integral of 3 square root of 3 over 2. 0. X to the power 3 over 4x squared plus 9 3 over 2 ds. Alright, so looking at this question, I would like to clean everything away. So think about the question. Looking at this question, you can see that u substitution will not work because when you set u to be equal to the inside here, and when you differentiate it, look at the power and the power. You see, it will not work. It will not work. Even if you work, you will suffer some more on your way. So let's go by. We know that here 3 square root of 3 over 2 0 x to the power 3 is over. Now with this, we can write this as 4x squared plus 9 all to the power what? 3. Alright? Because this can give us this. Then we get ds. So having this, we can write, we can bring out only this. We can bring out only this, that we're going to get 2x all squared plus 3 squared. So from our Pythagorean. Now, here is plus, so straight away, it's going to be tan inverse. So it's going to be tan theta. So here is going to be the hypotenuse. 4x squared plus 9 is the same as this. And tan theta is going to be the variable 2x over what? 3. So the tan theta is y over what? X, which is opposite over what? The adjacent. Alright? So here we get 3 tan theta is equal to 2x. So s is equal to 3 over 2 tan theta. So you divide both sides by 2. And when you find ds, you are going to get 3 over 2 differentiate tan theta. You get sec squared theta, d theta. Alright. So that is what we are going to have for that. Very good. Very good. Very good. So we have just, don't forget that this is just the square root of this, so we have all to the power 3. That will come in later. So now by substitution, we now have 3. Alright, so by substitution we now have this over 2, 0. What is s? S here is 3 over 2 tan theta. 3 over 2 tan theta cube. All this over square root of 4s squared plus 9 all to the power 3 ds, and the ds here is 3 over 2. Solving a question like this, you need to take your time, alright? You need to take your time. If not, you commit simple error. And there is no error. That is easy like that. Okay, so having this, we can see that, oh, don't worry. We didn't do the substitution of the s here. So we get 4 4s squared, right? And we have s to be taken, so 4 times let me write everything again. So in the inside here, don't forget that we have all these to the power 3. So the inside here we have 4. Now the s is 3 over 2 tan theta plus 9. Alright. Squared. So that is the s. That is the s. So now let's continue. The constants we have here is 3 over 2. Then the integral of 3 square root of 3 over 2. 0. Now when you square the 3, what will you get? So let's do that for that. 3 over 2 all to the power 3. We get 27 over 8. 27 over 8 tan that. All this over. Now here, good. Here we are going to have to the power 3. And the inside here we are going to have 4 times 9 over 4 tan square theta plus 9. So you see this will cancel this. Take your time and do it. We have already factored the 3 over 2 there out. So the 3 over 2. We have already factored that out. So here is sec square theta d theta. Very good. So look at what we have here. This constant will multiply this constant. Okay? So here we have 3 over 2 times 27 over 8. Then the integral of 3 square root of 3 over 2. Then we have tan raised to the power 3 theta over, please, this is just the upper bound. Over here, we can factor this 9 out. 9 can come out. Then we have tan square theta plus 1. Okay? All to the power 3. But don't forget that to the power 3 will affect the 9 that you are factor out also. So all to the power 3. Okay. And here we get sec square theta d theta. Watch. So 3 over 2 times 3 over 2 times 27 over 8. You get 81 over 16. 81 over 16. Okay, so we get integral of 3 root 3 over 2. Here is 0. Now, from what we have here, we can get tan raised to the power 3 theta over here. Don't forget that we have the square root of that and also the power of what? The 9. So that place you have to be careful. We have to be careful, okay? Because we are going to get something like this. times square theta plus 1 to the power 3. Then the 9 there too, we are going to have 8 times 9 and all to the power 3. I hope you can see that. Sec square theta d theta. So okay, so square root of 9 all to the power 3. That is what we have there, and that is 27. And don't forget that this 81 over 16, all over what? Is all over the 27 here. Alright, it's all over the 27 here. And here we get integral of 3 square root of 3 over 2, 0. And what is left inside here? Here is tan all this square root of 1 tan square theta plus 1 all to the power 3. And here is sec square theta d theta. Very good. So we know that here is 81 over 16 all divided by 27. And we get 3 over 16. So we get 3 over 16 here. Please here, be careful not to multiply this 81 over 16 by the 27. Don't multiply by that because it's all over this. So it's like this is the same as over 1. So you multiply 81 over 16 times 1 over 27, not 81 over 16 times 27. Mostly, it's easy to commit that error. Okay? So here you get 3 over 2. Here is 0. Good. Now, looking at what we have here, tan raised to the power 3 theta over. Now, the whole of the inside here. We know that, watch. We know that sec theta is equal to square root of 1 plus tan square theta, alright? Sec theta or sec square theta is equal to 1 plus tan square theta. Then sec theta is equal to square root of 1 plus what? Tan square theta. So the square root of this all to the power 3 is going to be sec theta to the power 3. We are going to get it like this because this represents that. Please, I hope it's clear. Alright. And here we get sec square theta d theta. So that is what we have there. And let's move to this place. I don't want to do this. We will need it. Okay. So now 3 over 16 integral of 0,3 square root of 3 over 2. Now here tan raised to the power 3 theta over this will cancel this to be left with 1. So sec theta d theta. Alright? So that is what we are going to get there. So from here, then we move on. How are we going to do to solve this? So we know that here we can write, we can set something to be equal to something and see what we are going to get. But let's see. Let me clean this part. Alright, let's continue. So don't forget about the lower bound and the upper bound. We will come back to it, okay? So now we have tan square theta over sec theta. Okay, so let's move on. We know that with this, we can rewrite this as 3 over 16. I will be using this, so I don't want to do it. 3 square root of 3 over 2, 0. Now, with this tan cube over theta, we can write that as 1 over sec theta times tan cube d theta. Okay? And we know here is 0, 3 square root of 3 over 2. The whole of this is going to give us what? Cos theta. Cos theta, because that's reciprocal. Cos theta. And it's going to multiply by this. But this is the same as sine cube theta over cos cube theta d theta. And this will cancel one of this. So 3 over 16 square root of 0, 3 root 3 over 2. And here we are going to get sine cube theta over cos square theta, because this will cancel one of this, the theta. Okay. So from what we have here, we can still continue and solve it, because we know that here 3 over 16 square root of 0, 3 over square root of 3 over 2. Watch. We can rewrite this as do you know the reason why we are doing that? So that we can do a substitution of trig identity here, because sine square here is the same as what? 1 minus cos squared. 1 minus cos squared theta. So here wow. 3 over 16 square root of 3 root 3 over 2, 0. Here we are going to get 1 minus cos square theta over cos square theta. Alright? Times sine theta d theta. So that is that. That is that. Do you know why we are doing all these things? The reason why we are pushing one of the sign here to get a Pythagorean identity, that is trig identity here, to do substitution is that here, by doing substitution, you can let u to be equal to cos square theta, okay? And when u is equal to cos theta, and when u is equal to cos theta, du is going to be sine negative sine theta d theta, and that is exactly here. Alright, so when you negate both sides, you get negative du is equal to sine theta d theta, and sine theta d theta is exactly what we have here. So this is going to be negative du. Very good. I love calculus. So here we are going to get 3 over 16 square root of 3 over 2 zeros. Then with this, when you see cos, put u there. 1 minus u squared over 1 minus u squared. Yeah, that's a square. So 1 minus u squared over u squared. And all of this is negative du. So negative 3 over 16. Oh, keep bringing it, keep bringing it, keep bringing it, keep bringing it. And here we are going to get 1 over u squared minus u squared over u squared du. Oh, we are getting something nicer. Okay, so let's bring back again. So after getting to this part, don't say that, oh, I'm locked up, I can't continue again. We can continue by transforming this tan and sec to cos and sine. And when you do that, you see everything will be cleared off for you. Good. maintaining this. So from here we come to here. Negative 3 over 16 square root of 3 over 3 over 2, 0. We get u raised to the power negative 2 times 1 du. 1 du. And right after here, I will tell you something, okay? Now, I hope you can now integrate. Oh, it's minus. Alright, good. But here, right after setting u to be equal to this, we should have changed the upper bound and the lower bound, because you know that the upper bound and the lower bound that we have here is a variable x, and we have already established that in the rating definite integral videos. So that is that. Or you can choose to maintain it and later apply it. Which one do you like? Let's maintain and later apply it. No problem. Let's maintain. Because you have to do the substitution in that time. Good. So let's maintain it for now. So here we can now integrate this. So negative 3 over 16. When you integrate this, you add 1 to this, you divide by it, minus, we are integrating as respect to u, so this will be u. No more plus c, but rather you bring this, 0, 3 square root of 3 over 2. Don't forget that. So with this, let's continue. We have cleaned the board about 3 times, but we are still not yet done. Don't worry, that is mathematics. Let's continue. Don't forget, don't follow the long steps, but the concept behind each steps. Okay. Okay. So here we have 1 over u, negative 1 over u, minus u. Since we didn't change this, don't go and do the substitution. Now watch. We know that u is what? U is cos theta. So negative 3 over 16. U is cos theta. So here we get 1 over cos theta minus cos theta, because u is cos theta. No problem here. Okay, so that is that. Let's continue. So after the substitution, you can see that this will affect the inside. So here we are going to get negative 3 over 16, and when you multiply it by this, you get 16. You can get 16 cos theta plus cos theta. This will affect this plus cos theta, then 0.3 over 2. Now here we need to transform back our x's. If not, we can't do the substitution of the what? Of the upper bound and the lower bound. And I'm not basing on even the limit. I'm assuming as if the limit is not given to me. How are you going to do that? That is what I'm using to solve this one question. So don't forget about the upper limit and the lower limit. Here we need to transform back our x. So from here, now that we are going to use this, from here, let me clear this part. We are going to use only this Pythagorean this right angle triangle. We need cos theta to come and do the substitution back. So from here, what is cos theta? So we can see that cos theta is what? S over R, or the adjacent over the hypotenuse. So cos theta is going to be the adjacent, which is 3, over the hypotenuse, which is 4s squared. Alright, so here you get that, and that is what is here. Okay, so by substitution to this, we have this already. So by substitution, this bam, alright, not lot bam, just bam. Okay, so here you can now get this. Okay, multiply this by this, you get this. Okay, plus this over this. Now, negative 3 all over this. This is the same as negative 3 over 1. So we can now reciprocate this. Okay, so it's the same as you multiplying negative 3 over 1, multiplying by, so negative 3 over 1, negative 3 over 1, multiplying by, I have to put in everything here. This is going to multiply by square root of 4s squared plus 9 over 48. Because negative 3 over 1 times the whole of this. Okay, so it's about negative 3 multiplied by the reciprocate of this. So here you get negative 3 square root of 4s squared plus 9 over 48 plus 3 square root of 4s squared plus 9. And we have 0, 3 square root of 3 over 2. Alright, so in case you have a question in indefinite integral, that means that you will leave it as this. Then you add plus c. And if it's definite like what we have, what you'll be doing is that now that you have transformed back your s's, you now do upper bound minus what? The lower bound. And when you do the substitution straightforward, your result is going to give you 0.09375. Alright? Another way to confirm this answer is just punch this question, the whole of this question, on your calculator, and press on solve or equal to give you the approximate value. So that is what we have for that. Okay, so let's see. Question 9. Question 9. So under the techniques. So question 9 here is indefinite integral. So let's move on and go away. Quick. We know what this is going to be. Let's bring out this. So this x squared minus 9, theta will be here. This is a sine. This is positive, so the s will come here. I have already told you not to chew this. This here is going to give you 3 squared. So if you have this here, then let's try sec theta. Sec theta will be r, that is the hypotenuse over the adjacent. So s over the adjacent. That means that there should be a constant 3 here. So this will be s squared minus 3 squared. That will be here. which is 9. So here is 3. So s is equal to 3 sec theta. So the s is equal to 3, differentiate sec, we get secant. Sec theta tan theta d theta. Very good. So that is what we have for that. Let's go and use the substitution. Integral of 1 over the s we have there, the s square we have there, we have 3 sec theta all square, and the integral of 3 sec all squared minus 9. Alright. And that we get the s to be 3 sec theta tan theta d theta. Very long, but just simple. It just helping you, okay? So 1 over here we get 9 sec square theta square root of 339 sec square theta minus 9. Here we get 3 sec theta. Wow. Okay. So looking at the constants here, we can get this one out. 3 over 9 come out. Sec theta, tan theta, all this over sec square theta. And with this, we can factor 9 out, and we take the square root of the 9, so we get 3. Hope you can see what I'm doing. And here we get sec square theta minus 1 theta. This will come and multiply this. We get 3 over 9 times 3. Okay? And we get integral of sec theta tan theta, all these over square root of sec square theta minus 1 d theta. So from here, hey, I forgot to bring something. This sec theta. Don't forget to bring it. So here we are going to get 3 over, this will cancel this, so we get 1 over 9 integral of sec theta tan theta over, you know that the whole of the inside here is going to be what? That is going to be tan square. So we get sec square theta square root of tan square theta. The inside here is tan square d theta. So having this will take away this, we get 1 over 9 integral of sec theta tan theta over sec square theta tan theta theta. This will take away this 1 over 9 integral of 1 over sec theta d theta, because now I want to take one of this. that is that. Let's continue now. From here, don't forget this s squared is there, right? So from here we know that 1 over 9 integral of this is what? Cos theta d theta. And we can now integrate cos theta. So when you integrate cos theta, I don't want to bring this side. Please, I'm going to bring this side. Alright. Hope I can clean it now. So here we know that 1 over 9, when you integrate cos, you get negative sine theta plus c. It's indefinite, so plus c. Alright, so from here we need to bring back. Okay, so from here we need to bring back our x's. But with this, we know that, so from a triangle, sine theta will be equal to back. Sine theta will be equal to opposite over the hypotenuse. So the opposite, which is y s squared minus 9 over the hypotenuse, and that is s. So therefore we get negative 1 over 9 times the square root of s squared minus 9 over s plus c. So definitely we end up by getting negative square root of s squared minus 9 over s plus c. So don't forget 9s. So that becomes our general solution, and that is our final result for that. Very good. We continue with our 10th question, question 10. Yes, we need to solve more examples. We need to solve more examples. So with this, when you bring out this 3 squared minus s squared, you see that this substitution will not work. Whew, okay. Oh, that is the one here is the positive, so that will come here. So I think we should try on sine theta, because sine theta will be something over a constant, alright? And the constant is the hypotenuse. Y over r. So the y will be here, that will be x. So s here. Then this one will be here. 3 squared minus s squared. So we get s equal to 3 sine theta. So ds is equal to 3 cos theta d theta. So let's go and do substitution. So s is what? 3 sine theta over 3 square root of 9 minus s is what? 3 sine theta squared. And ds is what? ds is 3 cos theta theta. 3 cos theta theta. So from this, we can now have integral of 2. We can now have the integral of 3 to the power 3 is what? 27. Okay, sine to the power 3 theta square root of 9 minus 9 sine square theta times 3 cos theta d theta. Okay, so now the 3 will multiply the 27, then we get 4, 2, 3. 2, 4, 3 rather, 2, 4, 3, and that will come out. So sine to the power 3 theta. Then the whole of this, let's try. 27 times 3. Oh, 81. I know where the 2, 4, 3 I don't say is coming from, but let's bring this first. Now this one, we can factor 9 out and take square root of 9, we get 3. So we get 1 minus sine square theta cos theta d theta. First of all, know that 3 will multiply this, you get this. When you factor 9 and square the 9 and square root the 9, you get 3. Now the 3 multiply this, that is where you will be getting 2, 4, 3. That's where you will be getting 2, 4, 3. When this multiply this, so we get sine to the power 3 theta times. Now the square root of this is just going to give you cos theta, okay? Because we know that cos square theta is equal to 1 minus sine square. So when you take the square root, that is that times cos theta d theta. So here you get 2, 4, 3 square root of sine cube theta, and this time this you get cos square theta d theta. Alright, so having this, we are almost there. Integral of, now we are going to do something, okay? We are going to do something interesting. We know that here we can push, we can write this and bring cos and bring sine theta here, then the cos theta d theta. This is exactly this. Okay. So the reason is that we want to bring a Pythagorean identity here, and that Pythagorean identity is going to be, let's see what it's going to be. So 2, 4, 3 integral of 1 minus cos square theta. Then we are going to have cos square theta. Let's bring this one. Let's do this one. Then let's bring this sine theta d theta. Now see something. If we set u to be equal to cos theta, if we set u to be equal to cos theta, you can see that we get du to be equal to what? Negative sine theta d theta. And when you square both sides, you get negative du is equal to sine theta d theta. And sine theta d theta is exactly what is here. Beautiful. I hope you can see that. Alright, so 2, 4, 3 integral of 1 minus, this is what? U. So u squared. Then this is what? U squared. We know that what we have here is negative du. So du and the negative will come to this side. Huh. Let's continue. So negative 2, 4, 3 integral of this times this u squared, this times this, minus u raised to the power 4 du. Very good. I'm sweating, eh? Right. So now I don't want to clean this because I will use it. I hope that now I can clean this side. negative 2, 4, 3, the integral of, when you integrate this, you are going to get u to the power 3 over 3 minus, when you integrate this, you get u to the power 5 over 5. Then you add plus c. You add your plus c. You add your plus c. So here, very good. We can continue with our algebra. Here we can continue with our algebra, but don't worry. Right, exactly. So now, we know that, but u is what? Cos theta. So negative 2, 4, 3. Then here we get cos cube theta minus cos to the power 5 theta over 3 over 5. I hope you can see that. Good. So we need to transform back our x's. So we need to bring out cos. So with this, we know that cos theta is going to be what? Adjacent, adjacent, which is adjacent 9 minus x squared over the hypotenuse, which is what? 3. So with this, negative 2, 4, 3. Then we get square root of 9 minus x squared over 3 all to the power 3 over 3 minus square root of 9 minus x squared over 3 all to the power 5. All this over 5 plus c. Alright. And when you simplify, good. So you can continue to simplify it, or you can also choose to leave it in that form. Okay? But when you simplify this, alright, when you simplify this, you are going to get negative 2, 4, 3. And you see the whole of this is just over 1. So multiply this by 1 over 3. So you just have something like 1 over 3, then the whole of that stuff over 3. Minus here to 1 over 5. Then the whole of that stuff over 5. Alright, plus c. So do that. And that will be the end of the question 10. Thank you. Is there any more other? Question 11. Question 11. Question 11. Alright, the question 11, actually I'm not more that interested in the question 11, but the question 12 I'm going to bring. So please, I would like you to take your paper and your book and your pen, calculator, and start solving the question 11 for me. Alright? And when you do it, you know that this is just the time you go your way, But when you do that, your final answer is going to be x squared plus 9 all to the power 3 over 3 minus 9 square root of x squared plus 9 plus c. That is going to be your result. And this question, all these questions is coming from Mr. Bichu book, alright, under calculus 2. So when you refer from that book, you can get a lot of questions also to solve it. Alright? So when you solve this question, this is going to be your final answer. Make sure you take your time and solve it. Alright, I'm more interested in the last question, which is the question 12. We have to evaluate let me refer, is it 9 or 8? Okay, it's 8. Alright, so that is the question 11 for you. Sorry, the question 12. Alright, our last question, that is question 12. We have to evaluate this. And we are saying by trig substitution and by hyperbolic substitution. By the hyperbolic, we should set our s to be equal to this and go our way. Alright, so let's go for A, by trig substitution. So, going straight to the point, we know that this square root of s squared, this can be written as this, and the square root of s squared plus a squared is tan inverse, sorry, is tan theta. So we get s to be equal to a tan theta. Alright, so the s is going to be equal to a sec squared theta d theta. So by substitution, I'm going to get the integral of a tan theta squared over, this is going to give us a tan theta squared plus a squared, and the ds is a sec squared theta d theta. Alright, so we are going to get a squared tan squared theta, all this over. Now don't forget that the whole of this is power 3. Okay. Here we are going to have a squared tan squared theta plus a squared, and the whole of this power 3, a sec squared theta d theta. So, alright, having this, note that I'm coming. Okay, let's move on. So, having this, note that with here we are going to get the integral of this a over by this a. So you get a raised to power 3 tan square theta over sec square theta, the theta there. Then we have here You see, we have the square root of the a square. We have a square here, a square here. We can factor the a square out. And when we factor out, we go and take the square root of it. But it will still be inside of this what? Bracket. And we get this to be tan squared theta plus 1. Plus 1. Alright. So that is exactly what we have now. Now we can see that here, the power 3 here will affect this and it will cancel this. So we are going to get tan squared theta sec squared theta over square root of tan squared theta plus 1 theta. So because this affects this will clear off. Tan squared theta sec squared theta, square root of that. Very good. So now, let's look at something. You can see clearly that the whole of this is sec theta. The whole of this is sec theta. So here we get, don't forget, this affects the A, but it don't remove that. It still affects this also. So the whole of the inside is sec theta. Then the power 3 will affect it. So we get integral of tan squared theta over this cancel this by the sec theta d theta. Sec theta d theta. Very good. I would like to clean this part. Okay, so now the integral of this, we can write this as sin squared theta over cos squared theta times 1 over sec theta d theta. Okay, and this is going to give us sin squared theta cos squared theta times cos theta d theta. It's a reciprocal identity. And you get sin squared theta over this cancel one of this, so you get cos theta d theta. Very good. So from Pythagorean identity, we can write integral of 1 minus cos squared theta, all this over cos theta d theta, to the one that we have here. I don't want to clean that part. Okay, you let me clean it. So you know that you are applying this already. So we are solving this question. Now let's move on. Where are we? From here, let's move to this part. Then later we come to this part. Okay. So from here, let's come to this part. So we get integral of 1 over cos theta minus cos squared theta over cos theta d theta. So here we get it to be sec theta minus, and this we get cos theta d theta. And we know that when you integrate sec theta, you get ln sec theta plus tan theta minus integrate cos theta, you get sin theta sine theta plus c. Alright. But don't forget that we are solving by trigonometric words substitution. So here we get a sum. So here is s squared plus a squared, and here is s, here is a. So we need to rewrite our s's back. So sec theta will just be, sec theta is the hypotenuse over the adjacent, the hypotenuse over the adjacent, and that is a. And we also know that sec, we also have tan, and tan theta is also equal to s over a. And what we have also sine theta. Very good. You can still get some way to write. Sine theta is also equal to the opposite over the hypotenuse. So you get opposite s over what? S squared plus a squared. So in all, by substitution in all, you are going to get ln sec theta is s squared plus a squared, all this over a, plus tan theta is s over a minus sin theta, which is s over square root of s squared plus what? A squared plus c. Very good, very good, very good. So we can combine this and write this as ln square root of s squared plus a squared plus s, all these over a, minus that, minus the whole of this. So that is the final answer for solving this question by trig substitution. Go back the video and watch it again and you understand it. Now let's go to the interesting part that I'm sure everyone is waiting for it. That is the hyperbolic substitution. Yeah, this, I'm sure everyone is waiting for that. And it's going to be interesting for us all. Yeah, I'm ready. Let's move on. So the B, which is by hyperbolic substitution, we were given that this is equal to A sin t. A sin t. So straightforward. Given that s is equal to this, we find the s, which is A cos t. Alright? So, but we are differentiating this as respect to t. So h cos t dt. Why not? Don't worry. Why not theta? Because the arguments for the substitution is not the same as this. So you need to take note of it, okay? Alright. Don't be using theta here. So by substitution, we get A sin t all squared, all these over square root of to the power 3, and we have the s to be A cos t dt. Sorry for my marker. I hope you can see it. Yeah. Sorry for my marker. Sorry. Alright. So now, here we get s squared, which is a sin t plus a squared, all these squared. Doing a substitution, you have to be taking your time, if not you will make a mistake. Here we get sin squared t, all these over. Here we get square root of a squared sin squared t plus a squared all to the power 3. And with this, we get a cos t dt. Very good. Now here, note that this will multiply this, so you get a raised to the power 3. And a square, when you factor out and take the square root of it, you get a. But the a will still be inside of the bracket. So the power 3 will affect it. It's the same as what happened in the trig substitution. So the a, you get a to the power 3 on top and a to the power 3 on top. So that will play off. And we are going to get sin squared t over square root of sin squared t plus 1. Don't forget this. Multiplying by, we have already multiplied it by this, and that's at 12. So we get cos t dt. Now, yeah. So now, here we are. But don't forget, we know that this is not the same as trig identity. So we know that cos squared t minus sin squared t is equal to 1. Please, I beg you, here is not plus, it's minus. This is hyperbolic substitution. So to make this a subject, we get cos squared t is equal to 1 plus sin squared t. That is why we have that here. So the whole of this sin squared t over. Now, when we take the square root of both sides, we get this. Okay? So the whole of this is equal to cos t to the power 3. And that is multiplying by cos t dt. I hope you can see from the board. Alright. So here we now get integral of sin squared t over, and here we get, don't forget that the cos t here to the power 1, here to the power 3, so we are going to get cos squared t going to be squared dt. Alright, so looking at what we have here, this is the same as tan squared t dt. So when you integrate tan squared t, what are we going to get? That's going to be somehow tedious for us, so don't worry. We know that tan squared t is going to be, let me first give it to you in this way. We know that sec squared, I'm not saying sec squared t is equal to 1 minus tan squared t. It's going to be 1 minus, not 1 plus, that is trig, it is hyperbolic. So to make tan square the subject, you're going to get 1 minus sec square t. So here we get 1 minus sec square t dt. Now when we integrate as respect to t, we are going to get the integral, which is I, to be equal to t minus, and when you integrate sec square, we are going to get tan square. So this integral of this, you get tan square t plus c. Tan, so we get t minus tan square t plus c. Oh, now we need to transform back. Okay, we need to transform back. So now, from here, we know that, please don't forget this result. Let me circle it here. From here, we know that to define this t here, we can get it here. We know that sin t is going to be equal to s over a. So t is just sin inverse of s over a. That is t is equal to sin inverse of that. Very good. And so we are gotten t. We now go and look for tangent, and that is where the work is. Please here, we don't draw the Pythagorean identity. You cannot say that sin t, so y over s. So you go and draw Pythagorean identity. No, that is for trig substitution. I beg you. That is for trig substitution. Don't go and draw that. Pythagorean identity don't work in hyperbolic. So what we are going to do is that we are going to use the identities to do it. So what we are going to do here is that we know from here that cos square t minus sin square t is equal to 1. Very good. Therefore, cos square t is equal to 1 plus sin square t. Don't forget also that we have sin t is equal to s over what? A. So what we want to do is that we want to get cos t so that we can use it to find tan short t. Good. So by substitution, you will get there very soon. So by substitution, cos square t is equal to 1 plus, we know sin t to be s over a. So here, we are going to get cos square t is equal to, here let's make it 1 plus s squared over what? A squared. To maintain the same denominator, cos square t is equal to a squared over what? A squared plus s squared over what? A squared. So cos square t is equal to a squared plus what? S squared, all this over what? A squared. So cos t is equal to the square root. Alright? That is going to be the square root of a squared plus what? S squared, all this over a squared. And that is going to be a squared plus what? S squared, all this over a. I trust you can see from the board. So, I don't want to clean this results. That is where we want to work to. So we know that cos t is equal to this. And here we know that, where is it? Sin t is equal to this. Very good. So all that we are doing is that we want to get sin t. But here we know that tan t is equal to sin t over cos t. Alright? So by substitution, we are going to get sin t is what? S over A. All this over cos t, which is square root of a square plus what? S square. All this over A. Very good. 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 So, I'm coming. Alright, so we know that sin is that, cos is that. So clearly, you can see that this will take away of this. Okay? But multiply this by the reciprocal of this. So you get tan t to be equal to s over square root of a square plus what? S square. I'm coming. Okay, let's quote from here. But let's quote from, we know that tan square t is equal to 1 minus sec square t. Alright? Okay, so we know that tan square t is equal to 1 minus sec square t. Okay. So from here, we know that this is the same as 1 minus 1 over cos square t. Therefore, 1 minus 1 over cos square is this. So we just have to square it. Square root of a square plus s square over a all square. So here we get 1 minus, don't forget, you're going to get 1 over a squared plus s squared over, the square will remove this root, so you get a squared. So finally, you are going to take the reciprocal of this. You are going to take the reciprocal of this, and this tan square t. I don't want to do that one I have there. So we get tan square t to be equal to 1 minus a squared over, yeah. Okay, so this one we have here is like 1 over 1. Okay, it's like 1 over 1. So that will multiply by this. So we are going to get, you got, don't forget that here is 1 minus 1 over. So this is like 1 over 1. Then there's a fraction, there's a fraction. So you get a squared over a squared plus s squared. Now, we want to achieve the same denominator here. Okay? So to achieve the same denominator here, you know that tan squared t is going to be a squared plus s squared over a squared plus what? S squared plus a squared over a squared plus what? S squared, to achieve the same denominator. So tan squared t is going to be equal to, oh sorry, here is minus. Let's add the top. A squared plus s squared minus what? A squared. All these over a squared plus what? S squared. So here we get tan t is equal to, or tan squared t is equal to, this will play on this. So we are going to get s squared over a squared plus s squared. Alright. So when we take the square root, we are going to get tan to be equal to, we are going to get s over the square root of what? A squared plus what? S squared. And this is the same as when you get to this side, without using this formula, you can use the one that I first go by and claim it to use this approach. But I was trying to see if in all we are going to get the same results, and surely we are getting the same results, because we know that tan t is equal to what? Sin t over cos t. So we were having sin t and cos t, so by dividing all that one also, we are going to get the same as this. And by going by 8 in this way also, we are going to get the same as that. So in that case, you have to approach this. But we know tan to be this, and we only know t to be, what was the t? I have cleaned that part. We have the t already, and the t is sine inverse. Sine inverse of s over a. Sine inverse of s over a. So finally, our integral by hyperbolic substitution is going to be, alright, is going to be, okay, it's going to be sine inverse s over a minus, and we have tan to be s over we have that to be s over square root of a squared plus. Now, this is supposed to be the final answer, alright, but we need to still use our algebra to reduce this. That is why we learned hyperbolic inverse. So sine inverse is the same as this. Therefore, here we are going to put t to be equal to s over a, and that is what we are going to get here. Alright. So by substitution, we get this, and to achieve the same what denominator, here is s squared over a squared, and here to a squared over a squared, which is the same as 1. We are going to get this. Okay. So we get the s over a plus s plus square root of a squared plus 1 s squared. All these over what? A. all this over A. So that is what we are going to get for that. So this means that, what this means is that Sanch inverse is equal to this. So wherever you see Sanch inverse, go and put this one there. Therefore, our final integral results, our final integral result is going to be s plus square root of s squared plus s squared over A minus s over square root of a squared plus s squared plus c. So that is going to be our final answer for that. In our next video, we are going to go for another technique, and that is integration by parts. Until then, know that you are loved. Bye bye. In case you haven't subscribed, please subscribe to get the notice of our uploads. Okay, we have a lot for you. This is just for the beginning. We have a lot for you. There are a lot coming on your way, so make sure you subscribe to our channel. And in case you want to support us, you can do so. Alright, you know the contact already. You can do so. And the contact is +233 +233 05578595997 for any support or enquiries or assistance. You can contact me on this number. And also, my reference book is Mr. Bichu book under calculus 2. Thank you. See you in our next video.